Hi students, in this class we shall be discussing exercise 5.1 question number 1 onwards. Okay, so prove that the function f of x equal to 5x minus 3 is continuous at x equal to 0, at x equal to minus 3 and at x equal to 5. We have to check the continuity for f of x at all these points. It is very clear that it is continuous at all points because it is a polynomial function, but still we need to show that this function is continuous. Okay, so here what we have is f of x. So f of x is given to you as 5x minus 3, correct? So at x equal to 0 also, f of 0 at x equal to 0, this is what we want to check. Okay, so at x equal to 0, what is the value of f of x? F of x is equal to f of 0 will be equal to 5 into 0 minus 3, which is equal to minus of 3. Okay, now let us check the left and right limits together because there is no breakage of the function here. Okay, so limit x tends to 0, f of x will be taken as limit x tends to 0. The definition of f of x is 5x minus 3. So it is 5x minus 3, and that will be equal to 5 into 0 minus 3, which will be equal to minus 3. So therefore, here the value of the function is equal to the limit of the function. So limit x tends to 0, f of x is equal to f of 0. Okay, so therefore f is continuous at x equal to 0. Same way we can check for x equal to minus 3 and 5. Okay, so let us go for x equal to minus 3. At x equal to minus 3, f of minus 3 will be equal to 5 into minus 3 minus of 3. Okay, that is minus 15 minus 3, which is equal to minus of 18. Okay, same way limit x tends to minus of 3, it is not from the left, it is negative 3. Okay, f of x will be equal to limit x tends to minus 3, 5x minus 3, because that is how the function is defined everywhere, right? So that will be equal to 5 into minus 3 minus 3, which is equal to again minus of 18. So therefore f is continuous at x equal to minus of 3. F is continuous at x equal to minus 3. Same way we can prove for x equal to 5. Okay, so at x equal to 5, f of 5 will be equal to 5 into 5 minus 3, that is equal to 15 minus 3 equal to 12. Okay, now limit x tends to 5. Okay, f of x, what is that? That is limit x tends to 5, f of x will be replaced by the function 5x minus 3. It is the same process, and that equal to 5 into 5 minus 3, and that is again equal to 12. So therefore f is continuous at x equal to 5. Okay, so hope you are clear with the question. We shall move on to the next question. You can pause the video and note the problem. Okay, you can pause the video and note the problem. Let us move on to the next question. So the next question states that we need to examine the continuity of the function f of x equal to 2x square minus 1 at x equal to 3. So here f of x is given to you as f of x is equal to 2x square minus 1. Okay, we need to check the continuity at point x equal to 3. Okay, so first of all, first step is that we find f of 3. What is f of 3? F of 3 is 2 into 3 the whole square minus 1, okay, which is equal to 2 into 9 minus 1, which is equal to 18 minus 1, and that is further equal to 17. Okay, now the next step is to check the limit. Okay, limit x tends to 3 f of x. Okay, the limit of the function at 3 should be equal to the value of the function at x equal to 3. So that will be equal to limit x tends to 3 f of x is 2x square minus 1, which is equal to 2 into x square means it is 3 square, okay, minus 1, which is again equal to 2 into 9 minus 1, that is 17. Okay, so therefore the limit of the function is equal to the value of function. Limit x tends to 3 f of x will be equal to f of 3. Therefore f is continuous at x equal to 3. Okay. Now we shall move on to question number 3. Look at this question. Examine the functions for continuity. This is the function given to you. We have f of x. F of x is equal to x minus 5. We need to check whether f of x is continuous or not. So therefore let c be any real number. Let c be any real number belong to R. Okay, let c be any real number. So what is the value of this function at c? First thing is we will check whether the value of the function exists at c or not. So f of c will be equal to c minus 5. That is very clear. Okay, we just put the value of x equal to c and we get c minus 5. Okay, now we check whether the limit exists or not. Okay, that is limit x tends to c f of x will be equal to limit x tends to c f of x is x minus 5. Okay, and that will give you equal to c minus 5. Okay, so here very clearly this is equal to f of c. So limit x tends to c, f of x is equal to f of c. Therefore f is continuous on all real numbers or for all real numbers, continuous for all x belongs to R. Okay, next question. Next question is, here the function given is f of x is equal to 1 by x minus 5. Okay, where it is clearly x is not equal to 5. So the function is not defined at x equal to 5. So we will ignore that point. Okay, so therefore let c be any real number. Let c be any real number. Any real number such that c is not equal to 5. Okay, C be any real number such that C is not equal to 5. Now, what happens when it is less than 5? What happens when it is greater than 5? Both cases, the function is defined equally. Okay. So, therefore, f of C is equal to 1 by C minus 5. Okay. So, now we shall check the limit of the function. So, limit x tends to C, f of x will be equal to 1 limit x tends to C, f of x was defined as 1 by x minus 5, and that is equal to 1 by C minus 5. Okay, and this is from 1 clearly equal to f of C for all C not equal to 5. Okay, so limit x tends to C, f of x is equal to f of C for all the points in the domain of the given function. So therefore f is continuous in its domain. Okay, it is defined for all real numbers except 5, so it is defined and continuous in its domain. Okay, let us move on to the next question. Okay, look here. For this question, f of x is equal to x square minus 25 by x plus 5, where x is not equal to minus 5, so that the function can be defined. So here we shall first of all simplify the function to say this is x square minus 25 by x plus 5. Okay, this can be simplified further as say x plus 5 into x minus 5, a square minus b square formula. Okay, divided by x plus 5. Okay, now this will be equal to, see, you can cancel, we can cancel x plus 5 from both the sides because it is not equal to 0, right? And hence we have f of x equal to x minus 5. Okay, f of x equal to x minus 5. Now this is similar to the first question where we can take, now let C be any real number, Okay, so therefore what is f of C? F of C will be equal any real number which is not equal to 5. Okay, so f of C will be equal to C minus 5. Okay, now limit x tends to C. What is f of C? Limit x tends to C, f of x is equal to limit x tends to C, f of x was defined as x minus 5. Okay, and that is equal to C minus 5, which is equal to f of C from the first equation. Okay, so therefore f is continuous for all real numbers except minus 5. C is not equal to minus 5. F is continuous function in its domain. Okay, next question. Let us look at the next question. Here what we have is the modulus function. Okay, so f of x is given as modulus of x minus 5. We know the modulus function is split into two parts, right? First one, when x is greater than 5, what happens, and when x is less than 5, what happens? Okay, when x is greater than 5, this part comes out to be positive itself, otherwise it is negative. Okay, so therefore it will be equal to minus of x minus 5 when x is less than 5, otherwise it is defined as x minus 5. That is, when x is greater than or equal to 5, we can define it as the positive way as it is. Okay, now here we have three cases. That is, either x is equal to 5 or x is less than 5 or x is greater than 5. Okay. So, here let C be any real number. Okay. Then either C is equal to 5 or C is less than 5 or C is greater than 5. All these three cases have to be discussed separately. Okay. Now, if C is equal to 5, this is our first case. Okay. If C is equal to 5, what is f of C? F of C is equal to, it is defined from this position. From this position, what is it? It is equal to, C is equal to 5. Therefore, it is 5 minus 5 and that is equal to 0. That is 5 minus 5 and that is equal to 0. Now, we will consider both the left hand limit as well as the right hand limit for x equal to 5, right. So, limit x tends to 5 from the left, f of x is equal to, okay, x tends to 5, f of x from the left is equal to limit x tends to 5 from the left, f of x was defined as minus of x minus 5, and that will be equal to, when you put x equal to 5, you get 5 minus 5, 0, or that is minus of 0, that is equal to 0. Same way, limit x tends to 5 from the right, f of x will be equal to what? It will be equal to limit x tends to 5 from the right, f of x was defined as x minus 5, and that again when you put x equal to 0 will be x equal to 5, we will get 5 minus 5 is 0. So, we can say that the f of C is equal to the left hand limit and it is equal to the right hand limit. Therefore, f is continuous at 5. Therefore, f is continuous at x equal to 5. Okay. Now, we shall move on further. What if C is less than 5? If C is less than 5, what will happen? Okay, what will happen when C is less than 5? When C is less than 5, we have limit f of C. F of C is defined as minus of C minus 5. Correct? Clearly. And that is equal to 5 minus C. Now, for limit x tends to C, f of C, here it is less than C, it is defined like this. So, that is equal to limit of x tends to C, f of x will be equal to minus of x minus 5, and that is equal to minus of C minus 5, which is again equal to 5 minus C. We can see that this value and this value are equal, and therefore f is continuous at x less than 5 or for x less than 5. Same way we can show for x greater than 5. Okay, if what happens if x or C is greater than 5. Okay, here also f of C is equal to C minus 5, which is equal to C minus 5. Okay, so therefore this is defined. Now limit x tends to 5 or x tends to C. Okay, limit x tends to C, f of x will be equal to limit x tends to C. What is f of x? X minus 5. Okay, so that is equal to C minus 5. So you can say that these two are equal. Okay, so therefore f is continuous for x greater than 5. Now we have shown that f is continuous for x greater than 5. It is continuous at x equal to, it is continuous at x less than 5 also. So therefore f is continuous everywhere. on R. Okay, f is everywhere continuous. Okay, now we shall move on to question number 4. To prove that the function f of x equal to x is continuous at x equal to n, we need to show that it is continuous at any integer. Okay, it is continuous at any integer. Let n be any integer. Then what happens? Okay, so f of x is equal to x. Now let n be any integer. Let n be any integer. Then what happens? What is f of n? F of n will be equal to n. F of n will be equal to n, right? Now if the limit of this function f of x, okay, for x tends to n will be equal to n, in that case the function becomes continuous for n. Okay, so that is equal to limit x tends to n. What is f of x? X, okay, and that is equal to, when you put x equal to n, you get n, correct? So therefore f is continuous. Therefore f is continuous for all n, where n is a positive integer. Okay, f of x is equal to x is continuous where n is a positive integer. Now we shall look at question number 5. Just look at this question. It is distributed at x equal to 1. So it seems to be discontinuous at x equal to 1. Let us see what happens. Okay, so f of x is defined as f of x equal to x. Okay, if x is less than or equal to 1 and it is defined as 5 is x is greater than 1. So we need to check the continuity of this function at x equal to 0, at x equal to 1 and at x equal to 2. Okay, now let us check it at x equal to 0. For checking continuity at x equal to 0, we will first of all find the value of the function at x equal to 0. So f of 0, what is f of 0? F of 0 is equal to 0 means this function will work. X equal to 0, this function will work and it is equal to x. F of 0 is equal to 0, right? Also when it is approaching 0 from the left and right, it will be again defined by the same function. Therefore limit x tends to 0, f of x will be equal to limit x tends to 0, x, and that again is 0. So therefore f is continuous at x equal to 0. Okay, now we shall check the continuity at x equal to 1. Okay, let us check the continuity at x equal to 1. So for that, f of 1, what is f of 1? F of 1 is equal to 1. Okay, again the same function works. Okay, but at 1 the left limit and the right limit are different. So limit x tends to 1 from the left, f of x will be equal to limit x tends to 1 from the left. What is f of x from the left hand side? From the left hand side it is equal to x, and that is equal to x, and that is equal to 1. Okay, now limit x tends to 1 from the right, f of x, okay, that is equal to limit x tends to 1 from the right. What is x? Sorry, f of x is defined as 5. Here we cannot put the value of 1, so that's why it is 5 itself. So here what happens is that these two are not equal. So therefore this function is discontinuous, not continuous. F is not continuous at x equal to 1. You can say that the function is not continuous at x equal to 1. Not continuous at x equal to 1. Same way we can check for x equal to 2, for x equal to 2, what happens? Okay, for x equal to 2, for x equal to 2, let us check the continuity for x equal to 2. Okay, here the function, you should remember that the function was defined like f of x equal to 2 means it will be greater than 1. So, it is defined as 5 in any way. So, what is f of x equal to 5? Here f of x is equal to 5 for all x greater than 1. We know that. Okay. So, what is f of 2? F of 2 will be equal to 5. Also, let us check the limit. Okay. So, limit x tends to 2 from the left as well as from the right. F of x, it is defined as limit x tends to 2 from the left and right. Both the function is defined as, because just before 2 and just after 2 the values are going to be 5. Okay. So, therefore, it is equal to 5 and that is equal to 5. Okay. Here this 2 are equal. So, therefore, in this case also f is continuous at x equal. Okay. So, we have shown that the function is continuous at x equal to 0, it is not continuous at x equal to 1, and it is continuous at x equal to 2. Okay. So, only one point of discontinuity is present for this function. Okay. We shall move on to the next question, and the next question is question number 6. We need to find all points of discontinuity of the function f, where f is defined by f of x equal to 2x plus 3 if x is less than or equal to 2, and 2x minus 3 if x is greater than 2. Here clearly the function breaks at x equal to 2. Okay, it breaks at 2, correct? So, therefore, we will focus on that point. So, therefore, for x equal to 2, what is f of 2? F of 2 is equal to, it is 2x plus 3. When x equal to 2, it is defined as 2x plus 3. That is 2 into 2 plus 3, correct? That is equal to 4, 5, 6, 7. So, that is 7. Now, the left hand limit L, H, L. Left hand limit will be equal to, limit x tends to 2 from the left, f of x, that is equal to limit x tends to 2 from the left, f of x is equal to 2x plus 3. This is the function which defines the function when x is less than 2. Okay. So, that will be equal to, instead of 2, we will put 2 into 2 plus 3, and that is equal to 4 plus 3, that is equal to 7. Left hand limit is equal to the value of the function. Fine. Now, let us check right hand limit. Right hand limit also. Limit x tends to 2 from the right, f of x. In this case, f of x is defined in a different manner. Limit x tends to 2 from the right, f of x is defined as 2x minus 3. Okay, it is defined as 2x minus 3. So, it is equal to 2 into 2 minus 3, that is 4 minus 3 is 1. So, here clearly these two are not equal. Okay. So, therefore, here the left hand limit is not equal to right hand limit. Therefore, f is not continuous at, or discontinuous at x equal to 2. The problem is that this is your solution, or you can write either f is not continuous or f is discontinuous at x equal to 2. Now, we shall move on to the next question, question number 7. In question number 7, the function appears to be a very complex function, but that makes sense. Okay, let us simplify the function first of all. Let f of x is given to you as this way. See, x is already negative. So modulus of x will be minus of x. Okay, modulus of x when x is negative, see it is less than or equal to minus 3. So it is less than some negative number which is again negative. So therefore modulus of x for a negative number will be minus of x. Okay, so it is minus of x plus 3. Okay, and here when x is less than or equal to minus of 3. Okay, then we have minus of 2x when x lies between minus 3 and 3. 6x plus 2 when x is greater than or equal to 3. Okay, now we shall check for 3 and minus 3 because these are the points where it breaks. Okay, we can check at these 2 points. Which are the 2 points? We can check. See, it is minus 3. This is minus 3. At minus 3 and 3, the function breaks into different formulas, right? So therefore, we shall check the definition of the function at x equal to minus 3 and x equal to 3, right? So for x equal to minus 3. Okay, what is f of minus 3? F of minus 3 will be minus 3 is defined here. Okay, x equal to minus 3 is defined here. F of minus 3 equal to minus of 3 minus of minus 3 plus 3, that is equal to 3 2s are 6. Okay, now f of limit x tends to 3 minus x tends to minus 3 from the left and from the right, they are different. Okay, x tends to minus 3 from the left, x tends to minus 3 from the left. F of x, here x is less than minus 3. Okay, it means x is less than minus 3. What is f of x? That will be equal to limit x tends to minus 3 from the left. F of x is defined as minus x plus 3. Okay, it is minus of x plus 3, and that again when you put x equal to minus 3, it will be similar to this one. So it is minus of minus 3 plus 3, that is equal to 6. Okay, now for the right hand limit we will be defining limit x tends to minus 3 from the right. Okay, f of x, that will be equal to limit x tends to minus 3 from the right. What is the function defined as? It is defined as minus of 2x. So look here, it is from the right means it is greater than minus 3, greater than x is greater than minus 3, x is greater than minus 3. We can read it here clearly, that is minus 2x. So minus 2x will give you, instead of x you put minus 3, so we get minus 2 into minus 3, that is equal to 3 2s are 6 plus 6. Fine. So here all the points are same. So here clearly from these 3 points, from these 3 levels, we can say that here limit x tends to 3, f of x is equal to f of minus 3, sorry, x tends to minus 3, f of x is equal to f of minus 3. So therefore f is continuous at x equal to minus 3. F is continuous at x equal to minus 3. Even though the function is breaking, it is continuous at minus 3. Now we shall look at this portion where it breaks at 3. Okay, now let us go for the next part, that is for x equal to 3. Okay, for x equal to 3, for x equal to 3, for x equal to 3, we have checked for x equal to minus 3 and found that it is continuous at, f is continuous at x equal to minus 3. Now for x equal to 3, what happens? So for x equal to 3, we will find f of 3. What is f of 3? F of 3 is defined as, look at the function, when x equal to 3, it is defined as 6x plus 2. It is defined as 6x plus 2, x equal to 3. 6 into 3 plus 2, and that is equal to 18, 19, 20. Okay. Now we shall check the left hand limit and right hand limit. Left hand limit is defined as minus 2x and right hand limit is defined as 6 plus 2. Okay. Now limit x tends to 3 from the left, f of x, that is equal to limit x tends to 3 from the left, this is defined as minus 2x, right? And so it becomes minus 2 of 3, and that is equal to 6. Clearly this value may not be equal to the value of the function. Okay, minus, this is equal to minus 6, and also limit x tends to 3 from the right, f of x, that is equal to limit x tends to 3 from the right. What was the function? The function was defined as 6x plus 2. Okay, so that is equal to 6 into 3 plus 2, again that is equal to 20. So therefore here the left hand limit and right hand limit are not equal. The left hand limit and right hand limit are not equal. So therefore f is not continuous at x equal to 3. Okay, so f is continuous at x equal to minus 3, f is not continuous at x equal to minus 3. Let us move on to question number 8. Again, it is a similar question. Here we need to find out the point of discontinuities for this function when x is not equal to 0. Okay, x is not equal to 0 means when x is less than 0 or when x is greater than 0. Okay, so therefore what is modulus of x? We know that modulus of x is defined as modulus of x is equal to minus x when x is less than 0, and it is defined as x when x is greater than 0 or equal to 0. Okay, but in this case x is not equal to 0. Okay, so what happens here is f of x. Okay, f of x, the function defines itself as, say it is when x is less than 0, what happens? When x is less than 0, when x is less than 0, mod x is equal to minus of x. It becomes equal to mod x is equal to minus of x, right? Modulus of x by x, what does it become? When x is less than 0, the function becomes minus of x by x, right? So it becomes minus 1 when x is less than 0. Okay, so therefore it is equal to minus 1 when x is less than 0. Okay, also mod x by x will be equal to, see, mod x will be equal to x by x when x equal to or x is greater than 0. So therefore it is equal to 1. Okay, this is equal to 1 for x greater than 0, and it is defined as 0 for x equal to 0. Okay, this is called the signum function. Signum function, right? So for any negative number it will give the value as minus 1, for any positive number it will give the value as positive 1, and for 0, you know, it is 0. Okay, now for the given function, this function, we shall check the continuity at x equal to 0, because that is the only point where it gets broken into many pieces. Okay, so limit for f of 0 is equal to f of 0 equal to 0 clearly. Now what happens when x is less than 0? X is less than 0, limit x tends to 0 from the left, f of x, that is defined as minus 1. Limit x tends to 0 from the left, f of x is defined as minus 1 when x lies to the left of 0, right? So that is equal to minus 1. So that is minus of 1. And similarly, limit x tends to 0 from the right, for the right hand limit, we can say that limit x tends to 0 from the right. Okay, what is the function defined as? It is defined as positive 1 for x which is lying to the right of 0. So that is equal to 1 is 1. Okay, so here the left hand limit and right hand limit do not match. They do not match. and even they are not equal to the value of the function. So therefore f or the signum function is not continuous at x equal to 0. Okay, let us look at this question. This is also a similar question. Here again f of x is defined in different ways. Okay, so here let us simplify this thing. Okay, so that is f of x equal to, see, either the number will be less than 0 or x will be greater than 0 or it will be equal to 0. Okay, now if it is less than 0, when x is less than 0, what happens? Mod x becomes minus of x. Okay, that is mod x by modulus of x, right? When x is negative, what happens is x by modulus of x is equal to x by minus of x, right? When x is less than 0, mod x is equal to minus of x. That becomes minus of x will get cancelled, minus 1. Okay, so this is equal to this. Okay, f of x equal to minus 1 when x is less than 0, and it is equal to again minus 1. It is equal to minus 1 when x is greater than or equal to 0. That is f of x is equal to minus 1 for all x, right? When x is less than 0, then also it is minus 1. When x is greater than or equal to 0, then also it is minus 1. So therefore what we say, it is a constant function. Constant function is continuous. Okay, the constant function is continuous. So here f of x is equal to minus 1 for all values of x. So therefore f is a constant function, and therefore f is continuous for all x belongs to R. Okay. Next question, question number 10. Find the points of discontinuity of f where f is defined by the function as follows. Okay. So here we shall check the discontinuity at x equal to 1 only. Okay. So for x equal to 1. Okay. We'll check at 1. For x equal to 1, what is f of 1? F of 1 will be equal to, f of 1 will be equal, 1 is defined here. So it is 1 plus 1, and that is equal to 2. Okay. Now for the left hand limit, we need to check whether the f is continuous at x is equal to 1 or not. Okay. So x plus 1 is a polynomial function, so it is continuous in whatever domain it is defined, and x square plus 1 is also continuous for its domain. Okay. Now left hand limit. Okay, we'll check the left hand limit because 1 is lying here and everything is to the left of it and right of it is defined differently. Okay, left hand limit is equal to limit x tends to 1 from the left, f of x will be equal to limit x tends to 1 from the left. What is f of x? For the left of 1. Left of 1 means x is less than 1. When x is less than 1, it is x square plus 1. It is x square plus 1. Okay, x square plus 1. What is that? When you put x is equal to 1, not minus 1. Okay, it is 1 square plus 1, that is equal to 2. Fine. RHS. What is RHS? Sorry, RHL. Limit x tends to 1 from the right, f of x. Okay, f of x will be equal to limit x tends to 1 from the right. Here again what we took, it was x square plus 1, but here when x is greater than 1, we have x plus 1 as the function. So it is x plus 1. Again we get 1 plus 1, which is equal to 2. So here this and this are all equal. Therefore limit x tends to 1, f of x is equal to f of 1. So f is continuous at x equal to 1. Also it is continuous for all x less than 1, and it is also continuous at x greater than 1. Therefore f is continuous function for all x belongs to R. Okay, f is not a discontinuous function. So we shall meet in the next class.